Welcome colleagues. I've given the learners the following exercise 1.1 just to maybe try to practice. I'm going to mark few of them and move to exercise 1.1 as well into those activities. So the first one is given as number 1. We are having I squared, which we know, and then the second one is number 2. It's given as I to the exponent of 7, and number 3 is I to the exponent of 8. And maybe if we can also touch on number 9. Number 9, which is 1 divided by 2i. Remember the conjugate here. All right. The first one, I hope learners will understand that we said during the beginning of our presentation that I squared is equal to negative 1. But now if we are to simplify number 2, we need to recall that this is how we need to write it. We need to say this is I squared multiplied by 3, which is 6. 2 multiplied by 3, 6, but this one is 7. So it means here we are going to have I which is having another exponent of 1. Because when you multiply common bases, you add the exponents. So what we are going to have here is going to be negative 1 cubed multiplied by I, and the answer would be negative I. And then if you look at I to the exponent of 8, this one also we need to expand it to say this is the same as I squared. And then what we need here, we need 4, because 2 multiplied by 4 is 8. And then we know that we substitute the value of I squared. We said I squared is equals to negative 1 all to the power of 4, and the answer will be 1, which is positive 1. My interest is on number 9 on exercise 1.1. Let's look at number 9 on 1.1. Remember we said because we have numerator and the denominator, it means we must multiply by the conjugate. What is the conjugate of the denominator? The conjugate of the denominator is negative 2. It means the second step here will be 1 divided by 2i multiplied by negative 2i all over negative 2i. It means now what I'm going to have will be 1 multiplied by negative 2i is negative 2i. And then on the denominator, I know that 2 multiplied by negative 2 is negative 4. I multiplied by I is I squared. And finally, I have to substitute. Remember, I have 2i all divided by negative 4 into negative 1. Remember, I squared is equal to negative 1. So in other words, now the answer will be negative 2i all over positive 4. Why positive 4? Because negative 4 multiplied by negative 1 will give me 4, which is positive 4. And then if I have to simplify, the answer will be negative 1 all over 2i. The answer is in I notation. And if you recall, I also gave on exercise 1.2, I want us to look at a few of them as well, so that now our learners are able to at least break some ice, especially since it will be the first time they do them. Number 1 on exercise 1.2, let's look at number A, which is square root of negative 49. And then I also want us to look at number G, which is also having the numerator and the fraction, which will be negative 12 square root of negative 12 multiplied by square root of negative 6 all divided by square root of negative 2. And I'm also interested into number k as well. It's very interesting. K is given as square root of negative 12 multiplied by square root of negative 4 all over square root of negative 6. If you recall with the first example, I said square root of negative 49 will be the same as square root 49 multiplied by square root of negative 1. It will still give us negative square root of negative 49. Now, if we recall that the square root 49 is a perfect square and the square root of 49 is 7. And what did we say about the square root of negative 1? We said earlier that this is the same as I. It means now our answer is in I notation. But if we are to look at number G, it means I'll say 12 square root 12 multiplied by the square root of negative 1 multiplied by square root 6 multiplied by root of negative 1 all over root 2 multiplied by root of negative 1. You see, I'm not changing anything because root 2 multiplied by root negative 1, it will still give me square root of negative 2. And then when we come here, I think it would be easy for us to say, what is the value of square root of negative 1? We said it will be square root of 12i multiplied by square root of 6i. And what we have here, square root of 2i. And then having to simplify this, I'm sure you'll recall that square root of 12 is the same as square root of 4 multiplied by 3i, and then multiply by square root of 2 multiplied by 3i, all divided by square root of 2i. The reason being we want to see the like terms, and then if I have to simplify it, you will see that the square root of 4, it will be 2 square root of 3i multiplied by 2 square root of 3i all over square root of 2i. Now what we have here, it means we can simplify and say 2 multiplied by 2 is 4, and then root 3 multiplied by root 3 is 3. Remember, dot implies multiplication. And then what we have again here will be I squared all over square root of 2i. And if I have to simplify it further, you will realize that I can have here 12 into negative 1 all over root of 2i. And the answer will be negative 12 all over root of 2i. I'm sure we are following. Now the second one is number K as well. More or less the same approach, and I'm sure you will see here that we are given the square root of 12 multiplied by square root of negative 1. Remember, it still gives us negative square root of negative 12. And this one, remember, is multiplication dot, implies multiplication. 4 square root 4 multiplied by the square root of negative 1, all divided by the square root of 6 multiplied by square root of negative 1. And we realize that here we can have the square root of 12i multiplied by square root of 4 is 2i all over square root of 6i, square root of 6i. And we can always simplify further and say we can have 2 square root of 12i squared all over square root of 6i. And remember, when we simplify, we normally say 2 root of 12 into negative 1 all squared. Remember, it's not all squared because I squared is equals to negative 1. And then we are also having square root of 6i. And then as we simplify, we have negative 2 root of 12 all over root of 6i. And then our answer is still in the I notation. And if you recall number 2 as well, I think is also going to use the application of the perfect square. We're still simplifying here without using a calculator. And I'm sure if you look at number 2, the instruction here says simplify without using a calculator. Simplify the following without using a calculator. Now, when we look at the first one, number 2a. Number 2a is given as square root of negative 4 plus the square root of negative 16 minus the square root of 81, which is positive. This one is positive. Now, if we are to simplify this one, the procedure is still the same. Remember, this is root 4 multiplied by square root of negative 1 plus root of 16 multiplied by the square root of negative 1 minus 9. Where do I get 9? The square root of 81 is 9. And then if we are to simplify here, you will realize that the square root of 4 is 2. And then what is the value of square root of negative 1? We said is I, and then plus 4. 4 is the square root of 16, and then the square root of negative 1 is I minus 9. And if I have to collect the like terms, and the answer would be 6i minus 9. Now this is our imaginary part as well as the real part. And then now, if the complex number is this form, we call it the rectangular form like we said earlier on. And then if you recall that we also talked about the division and multiplication of complex numbers. But if you recall in our textbooks, I only gave exercises on 1.1 and 1.2. But if time allows me, I can also take learners through the division of complex numbers as well as the addition, multiplication, and subtraction. And then in most cases, we always have to, at least learners, be aware of the conjugate. If they can master how to write conjugate, if they are given the complex numbers. I said the conjugate will be when we change the sign of the imaginary number. If it's negative, its conjugate will be the positive one. If it's positive, its conjugate will be the negative one. And then when you turn to page 25, you will see the division of the complex numbers here when we apply the conjugate, where learners are expected to apply the conjugate. I'm going to take an example on page 25 where we have open bracket 1 plus 2i close bracket into negative 1 plus I, all divided by 2 minus I. I'm sure as a learner you can see that first of all we need to break the bracket. We need to multiply and later on now introduce the conjugate. So now the first step, what we do, we apply FOIL method. We have 1 multiplied by negative 1 is negative 1. And then 1 multiplied by I is I. And then 2i multiplied by negative 1 is negative 2i. And then 2i multiplied by positive I is 2i squared. I'm sure we are done. Remember we said 1 multiplied by negative 1 is negative 1. 1 multiplied by I is I, which is positive. But positive 2i multiplied by negative 1 is negative 2i. And then 2i multiplied by a positive I is going to give us 2i squared. And then we're still having our denominator as 2 minus I. And then I can simply simplify this one and say I'm having negative 1. These are the like terms. And then this will give me negative I plus 2 into minus 1. All divided by 2 minus I. And then as we simplify, we realize that we're going to have negative 1 minus 2 minus I all over 2 minus I. Where do I get this negative 2? Positive 2 multiplied by negative 1 is negative 2. And remember, these two are the like terms. And then if I simplify them, they give me negative 3 minus I all over 2 minus I. But remember, I need to simplify and leave my answer in the form of A plus BI. The answer must be in the form of A plus BI. This is what we call the rectangular form. Rectangular form, where we have real part as well as the imaginary part. This is the rectangular form, real part as well as imaginary part. So now, as we go on, remember we introduced conjugate, the conjugate of the denominator. The conjugate here will be 2 plus I, all divided by 2 plus I. Remember, you multiply the numerator and the denominator by the conjugate. So what you do on the numerator, you also do on the denominator. And then as you simplify, you say negative 3 multiplied by 2 will give us negative 6. Negative 3 multiplied by I is negative 3i. And then you come to the outer terms. I multiplied by 2. Negative I multiplied by 2 is negative 2i. Negative I multiplied by positive I is negative I squared. All divided by 2 multiplied by 2. It will give us 4. 2 multiplied by I, it gives us 2i. And then negative I multiplied by 2 is negative 2i. And lastly, I squared is going to give us negative I squared, because negative I multiplied by positive I, it will give us negative I squared. Now, as we simplify, you will realize that we are having negative 6, which is now negative 3i minus 2i. It will give us negative 5i, negative into minus 1. So now, as we are finishing, we are having 4, but 2i minus 2i, it will give us 0, and we are left with negative into negative. Remember, I squared is the same as negative 1. And then as I'm wrapping up, I'm sure as learners you're going through some activities, and most importantly, the examples are going to help us. And then we are having negative 6 plus 1 minus 5i, all divided by 5. Why 5? Remember, negative multiplied by negative is positive. Therefore, 1 plus 4 will give us 5. And then finally, the answer will give us negative 4 all over 5 minus I. Because remember, negative I, 5i divided by 5 will give us only I. So your answer is in rectangular form. In the form of what? A plus BI. What is the value of your A? Negative 4 divided by 5. And then your rectangular imaginary part will be negative I. I hope we're going to do most examples so that we're going to get used to these topics. And I want to encourage learners not to panic. They are still going to get it correct. They just have to go through the examples. Our textbooks are built with more examples as well as the activities. Thank you very much. See you next time.